Hi guys, in this video we're going to be learning about objects and object interaction. A class in Java is a template or a blueprint for an object, and you create these objects based on the class. The objects have got states and they've got behaviours, and these are through the form of variables and methods. So let's get straight into the code. If you open up your project, open source, main, Java, and then under the Java folder, we're going to create a new class. So right click, new, Java class. And we're going to call it car. So this class is going to represent a car. The car is going to have some data associated with that car. So it's going to have a make, private string make. And of course, make requires a string, private string model. So this will be the model name, private int current mileage. So this will be the mileage of the vehicle or the number of miles that that vehicle has gone at any moment in time. Private double fuel level. So this will be the current level of fuel within the car, and we've set that as a double because 1 is going to represent the maximum level of fuel, and that will go down as the vehicle drives. So as the vehicle drives, that will reduce by a set figure every time until we hit 0, and 0 means it's an empty tank. And finally, we're going to have a variable for the current state of the vehicle. So private string current state. So this current state can either be moving forward, turning left, turning right, or stopped. We're now going to create a constructor for the car class. So public car. This constructor is going to take two parameters, so it's going to enable us to initialize the make and the model with whatever is passed through as a parameter on the constructor, and the other three fields below, we're going to set them with a default value. So let's create the parameters for the make and the model. String make, string model. This dot make equals make, and this dot model equals the model. So this constructor is going to pass in the make and the model, and we're going to set it on the class. And as we said, we're going to set the current mileage. So it will have an initial mileage of 0 when we create an instance of the car class. The fuel level is going to be 1 because we said that was the maximum level, and as we go down it will go to something like 0.95, 0.9, 0.85 and so on. And the current state. So the current state is going to equal stopped, and that has to be a string, so it has to be in quotation marks, and we're just going to use all caps, so it's going to look like that. It doesn't quite like this because I've set the current mileage here instead of the current state, so it's current state. So now let's create some methods so we can manipulate the data within the car class. So we'll create a method public void move forward. It won't take any parameters, it's not going to return anything, and it's public because we need access to it from outside this class. And here we're going to set the current mileage to minus equals 1. So every time we run the move forward method, we're going to assume it's going to move forward 1 mile. We're also going to deplete the fuel level, so that's also going to be minus equals, and we're going to deplete that by 5%, or in other words, 0.05 of the fuel level. And the final thing is we're going to set the state. Current state is going to equal moving forward. And we need something similar for turning left and turning right. So public void turn left. Again, nothing as a parameter, and all we want to do here is set the current state to equal moving left or turning left. Let's create another method, public void turn right. Current state equals turning right. So as we said, a class is essentially a blueprint for an object, and this object has a state, so it has a bunch of values that we can set and manipulate, and it's got behavior in terms of these methods: move forward, turn left, and turn right. Now let's also include some getter methods. We need getter methods for each of these 5 fields. So let's type those out. Public string make. And that is simply going to return the make. Public string get model. And that is going to return the model. And as per the convention, we use get in front of the name. So it will be get model. And for this one above, I need to change it so that it's get make. This is a standard convention in the Java language that when you are creating a getter method or a setter method, then you would prefix it with get or set. Now we have another 3 here that we need getters for. So we can type them out, but there is an easier way to do this and as a shortcut in IntelliJ. So I'm going to right click, I'm going to click generate, getter. I'm going to select all 3 of these because these are the 3 outstanding fields that we don't yet have getters for. So on your keyboard, hold shift, click the current state, and you've now selected all 3. And click OK. And now you have the other 3 getter methods. So now we've created the car class, let's go ahead and create another class, and this one is going to be called driver. So it's going to represent the driver of that vehicle. So right click on the Java folder, again, new Java class. And we're going to call it driver and click on class. The driver class is going to have 3 fields. So private string name, private int age, and finally private car. The first 2 are fairly standard. We understand what they are, the name and the age of the vehicle. That makes sense. So this will be the name of the driver and the age of the driver. The third one is not something that we've used before. So instead of setting something like string or int or double, so we're now using a class that we have created in terms of the car class as a type for a variable on a new class. So this is how we're going to have our objects interact with each other to perform the application. So this app will allow us to pretend that we're the driver and that we can set commands as the driver, which will in turn make changes to the car. In other words, altering the current mileage, the fuel level, and the current state of the vehicle, which we'll be able to retrieve later to see how the vehicle object changes. So let's again create a constructor. Public driver. And this is going to take the name, so string name, and int age. This dot name equals name. This dot age equals age. And as part of this, we can also set the car. So once we instantiate a driver, we're going to supply it with a particular car. So a driver relates to a particular car. So car owned car. And we'll also call this variable owned car, so it's a little bit clearer. This dot owned car equals owned car. So as we said previously, an object will have a state and it will have behavior. We've given the driver some state in terms of a name, the age, and the car that they own. So the next thing we're going to do is give them some behavior in the form of methods. So public void accelerate. And this is going to represent the driver accelerating the vehicle and the vehicle therefore moving forward. So when we accelerate the vehicle, we want the car to move forward. So here we need to do owned car dot move forward. And as we defined in the car class, if we return to that on the tabs up here, as you can see here, moving forward will reduce the current mileage, but I've just realised that that needs to be plus because of course as we move forward the mileage of the vehicle will increase, not decrease, whereas the fuel level will decrease. So the current mileage increases by 1 for every time we move forward. The fuel level depletes by 0.05 and the current state of the vehicle is now moving forward. Noticing this, it might also be useful to have an ability to stop the vehicle. So let's add a method underneath turn right and we'll call it public void stop. and this will set the current state to stopped, which is also the same state as when we initially create an instance of the vehicle class. So back in our driver class, as we accelerate the vehicle, the car will move forward, altering some of the state of that car. We'll create another method, so public void stop vehicle. We'll also then call the car class, so owned car dot stop. Now we're going to create the methods to turn left and right. So public void turn left, and that will be owned car dot turn left. So here we're going to call the owned car object, and we're going to call the turn left method on that object. And the same for turn right. So public void turn right. Owned car dot turn right. And finally, for the driver, we're going to create a method to print out all the details of the driver, so the name, the age, and the details of the car. So public void display details. So we're going to use printout statements, driver name, semicolon, colon, sorry, leave a space, and the name. We'll do the same for the age. And then we'll create a print statement for the car. So car current mileage. And that will be owned car dot get current mileage. And we'll do the same for the fuel level and the current state. So fuel level, and we'll change that to get fuel level. And finally, the current state. So car current state. And that will be get current state. So just to reiterate, we've got the display details method, and that will print out 5 lines to the console with the name, the age, the current mileage, the fuel level, and the state of the vehicle. Another point to note here on the variables that we declare for the class, because of the fact that we're setting the name, the age, and the owned car straight away within the constructor, we can set each of these variables with a keyword of final. Final basically means that the values of the variables won't change once the object has been instantiated, and we know that for name, age, and owned car, they're all set on instantiation of the driver class. And if we go to our car class, this is also the case for the make and the model, because we set this straight away. However, the other 3 fields, they will change as we go on. So on instantiation, the make and the model will always be the same. So we can set those as final. They're only set once, so they won't be changed. So here we have the car class with each of its behaviors and some getter methods. We can also add the make and the model to our details. So I'm going to add 2 more printout statements, and that will be car make and car model. And that will be owned car dot get make and owned car dot get model. So we're also going to print these out and make use of those getters that we set previously. Now let's return to the application class. So as we said before, the main method in Java is our entry point into the application. So this is where we'll start and instantiate any other classes. So let's create an instance of the car class. So car equals new car. And as we said before, to create an instance of this car, we require a make and a model. Let's set the make as Ford and the model as Mustang. So we've created a car variable, we've instantiated a new car class with the initial values of Ford and Mustang. We're now going to declare and instantiate a driver class. So driver equals new driver. And again, the driver needs some information to create that driver object. It needs a name, so Amir. It needs an age, we'll say 30, and it needs a car object, because you can see here it needs a variable that is called ownCar, and that is of type car. So basically it means that we need to supply something here that is of type car, in the same way that we've supplied something of type int and type string. And we have a car here, so the variable here car is of type car. So we simply need to type car in here, and it'll refer to this variable name. We now have a driver. The first thing that we can do is do driver.displayDetails, and we know if we head back to the driver class and go down to display details, we know that the result of this method will print out all of these statements. So let's do that first. But before we do that, let's actually print out two more printout statements. And if we remove all of this, and within the brackets, let's just put some stars. So this will act as a separator when we display the details multiple times in the console. They're a little bit easier to see. So this is just 2 lines, just to leave a buffer between each set of printout statements. Now let's return to the application and let's run this class. So you can see here that we've instantiated the driver object, and we've called a method on that driver object, which if we move back to the driver class, you can see it located here. So this is what is printed out here. So driver name, Amir, driver age 30, Mustang, current mileage of 0, the current fuel level is 1, and the current car state is stopped. So underneath that, let's start moving the vehicle. So if we were to accelerate with the accelerate method on the driver class, and if we go back there, we're now calling the accelerate method. Because of the fact that we set this car object onto the driver, and we return to the driver, we're now referring to this owned car, because this owned car was set as a parameter here on the constructor, which is the one that we constructed already prior to constructing the driver class, gets passed in and set as a field here. We're then calling the move forward method of the car. And if we go to our car class, we know that move forward is going to increase the mileage, reduce the fuel level, and change our current state to moving forward. What we're then going to do is display the driver details again. Now, when we display the driver details again, these values are going to be slightly different. So the first 4 values will be the same, but the following 3 will be slightly different because the current mileage will increase to 1, the fuel level will have reduced by 0.05, and the current state of the vehicle will now be moving forward rather than stopped. So let's return to the application class. We've now called the accelerate method, so let's do driver.displayDetails. So we're going to have our initial details displayed, and then we're going to have another set of details displayed after we accelerate the vehicle and it moves forward. So let's play that. So as you can see here, our initial printout statement is here. Our following printout statement has the same data for the first 4, and now you can see that the current mileage has increased by 1, the fuel level has reduced by 0.05, and the car is now moving forward. Let's do another example. So if we were to do driver.turnLeft, let's head to the driver class. So when the driver turns left, it will turn the car left. In this case, calling the turn left method on the car class. So let's go to the car, and what happens in the turn left method here? The current state simply changes to turning left. So it doesn't modify the current mileage or the fuel level as it does in the move forward, it simply modifies the current state. If I was to add a third call to the display details, in other words a third set of printout statements, we would aim to see that the current mileage and the fuel level doesn't change, however the car's current state does change to turning left rather than moving forward. So let's play that. So from the top, the vehicle is stopped, no mileage is used, no fuel, the fuel level is still at the max. Our second one, the mileage is now 1. The fuel level is 0.95. It's moving forward. And as we said, on our next one, the car's current mileage is 1. The fuel level is still 0.95. However, this time we're turning left rather than moving forward on our car's current state. And let's do one final example. So let's say that we now want to have the driver stop the vehicle. So we'll do driver.stopVehicle. And if we go to our driver class, the stop vehicle method will basically call the stop method on the car that it is associated with. So let's go to the car and we'll look at the stop. And as we said, the same thing, it simply changes the current state to stopped. And to confirm that, back in our application class, let's do driver.displayDetails. So again, in this last display details, in this last set of printout statements, we'd expect the mileage and the fuel level to be the same. However, we'd expect the car's current state to now be stopped as opposed to turning left or moving forward. So let's play the application again. And you can see here now we have 4 printout statements with stopped, moving forward, turning left, and stopped again. And note how the mileage and the fuel level still haven't changed. So that's everything for this video. I really hope that made sense. We are going to go into objects and object interaction in much more detail in later videos, including creating some simple apps. Thank you very much for listening, and if you did find the video useful, then please don't forget to leave a like and subscribe.